Hello friends, welcome back to our channel. So in today's session we'll see one more concept in discrete mathematics, that is how to solve the second order homogeneous recurrence relation. So in our previous session we have seen what is the recurrence relation, what are the different types of recurrence relations, and also we have solved two problems, one on first order recurrence relation and second one on second order homogeneous recurrence relations. So today without delay we'll solve one more problem in this second order homogeneous recurrence relation. So before starting that, just recall the steps. So first we have to check whether the relation is in homogeneous and second order or not. So in order to finding the order of the relation, any relation is finding the difference between the highest order and the lowest order. So here the highest order is n and lowest order is n minus 2, so where the order becomes 2. So this is in second order homogeneous recurrence relation. Now in the next step, based upon the given relation, we have to find out the auxiliary equation. So finding the auxiliary equation, then we have to find the roots of a quadratic equation. As it is a second order, so obviously the equation will be the quadratic equation. Then we are supposed to find the roots of quadratic equation, and based upon the results of the roots, the three cases will be used. The first case, whenever the roots are distinct, different, so we'll be using one generalized solution formula, and if roots are equal, then we will be following the case 2 general solution, and if roots are imaginary and complex, we'll be using the third category, that is the general solution for that particular imaginary roots. So in our previous session we have seen the recurrence relation where the roots are distinct. Now we will solve this kind of problem. So here the problem, the relation is this one. So the auxiliary equation will be, so here 1, see C1 or Cn into k power 2 plus Cn minus 1 into k power 1 plus Cn minus 2 into k power 0. So here Cn is equal to 1, Cn minus 1 is equal to minus 6, Cn minus 2 is equal to 9. So based upon that we are applying the quadratic equation. So k square minus 6k plus 9 equal to 0. So now in this particular equation we need to find the roots. So you can write this one as k square minus 3k plus 9 is equal to 0, because if you add these two we'll be getting 6, if you multiply these two we'll be getting the 9k square. Yes, so take k as a common, k minus 3 yes, minus 3, take minus 3 as a common, so it will be k minus 3, yes, is equal to 0. Then it will be k is equal to 3, so we can and also k is equal to 3. That means here you can say the roots are equal. So for this roots are k1 equal to k2 equal to 3. So these are the roots. Hope you understood. This is the first one. This is the auxiliary equation. This is the auxiliary equation. So from this auxiliary equation we are finding the roots. So this is a one process. Otherwise you can also use a roots of a quadratic equation formula, minus b plus or minus square root of b square minus 4ac by 4a. So you can follow that approach also. Now among the three cases, I am erasing this one. Among the three cases, here what we got? We got the roots with a equal value. So roots are equal. Roots are equal. So general solution will be a k power n plus an is equal to a k power n plus b into n plus k power n. So this is the general formula. where we know k value. So an is equal to, we don't know the capital A, so where k is 3. So 3 power n plus, we know b, we don't know b. So b into, we don't know n into k power n. Again it is a 3 power n. So we need to find the a value and b value. So for that we are having the initial conditions a not equal to 1 and a1 is equal to 6. So if this one, now n is equal to 0, a not equal to a into 3 power 0 plus b into 0 into 3 power 0. So this becomes 0. So a not is equal to a, where 3 power 0 is equal to 1. So therefore a will become, a naught value, what is the a naught value? 1. So a naught value, a value will be 1. Now substitute n is equal to 1 because if we had a1, so it will be a1 is equal to a into, what is the k value? 3 power 1 plus b into, what is the n value? 1 into 3 power 1. So a1 value is 6. So 6 is equal to 3a plus 3b. Okay, sorry, 3b. Now let it be, this is equation 1. So from equation 1, a is equal to 1. So this becomes 3 into 1 plus 3 into b is equal to 6. So that implies 3b is equal to 6 minus 3. So 3b is equal to 3. So b is equal to 1. Now we are having the values a value and a b value. Now the general solution will become an is equal to, what is the a value? 1. 1 into 3 power n plus, what is the b value? 1. 1 into n into 3 power n. So that becomes 3 power n plus n into 3 power n, an. So this will be the solution for this second order homogeneous recurrence relation. Okay, so hope you understood. This is the second case. So in our previous session, we have also solved one problem of second order homogeneous recurrence relation, but there we got the roots are as a distinct roots. So but here the roots are equal. So this becomes a k only. K is equal to, so k1 is equal to k2 is equal to 3. So there are two roots because of its quadratic equation. If you go with the 3 order, so we'll be having three roots. Okay, third order homogeneous recurrence relation, we'll be having the 3 different roots. So that we'll see in our next session. Third order homogeneous recurrence relation, which is also called as a higher order homogeneous recurrence relation. Right? So hope you understood. So we need to remember the 3 formulas when the rule, the general solution, when the roots are equal, when the roots are distinct, and when the roots are imaginary and complex. So accordingly we will be having the initial conditions. If the question doesn't have any initial conditions, so this will be the general solution. Remember that. If your question is having the initial conditions, we need to find out the a and b values. If your question doesn't have the initial conditions, then this will be the general solution. Okay, so hope you understood this one. Let's stop here, and if you feel you enjoyed the session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.